Hello everyone and welcome to this video on AWS Dynamo DB. In this session, I will introduce you to Dynamo DB, cover its features, use cases, and core concepts, and also walk you through a hands-on example. Let's get started. Here is what we will cover today. What Dynamo DB is and why it's used. Key features that make it powerful. Core concept to understand how it works. Use cases where Dynamo DB is a perfect fit. A hands-on demo for creating and querying a table. Best practices to optimize usage and some limitations to keep it in mind. Let's get started. First, what is DynamoDB? DynamoDB is a fully managed NoSQL database service provided by AWS. It supports key value and document data models, making it highly flexible. With built-in high availability and durability, it's perfect for mission-critical applications. Additionally, it's serverless, which means AWS handles all the infrastructure and it automatically scales based on your workload. Here are some key features of DynamoDB. Scalability. It can automatically scale to handle increased traffic. Performance. It provides single-digit millisecond latency. Flexibility. You can use it as a key value store or as a document database. Integration. It integrates seamlessly with other AWS services like Lambda, S3, and API Gateway. These features make it ideal for modern applications requiring low latency and scalability storage. To use DynamoDB effectively, you need to understand its core concepts. Tables are collections of items, similar to a table in a database. Items are individual records or rows in a table. Attributes represent the columns or data points in an item. Keys are essential for querying and partitioning. Partition key is the primary key used to identify data. Sort key is optional and helps order data within a partition. Indexes like Global Secondary Index (GSI) and Local Secondary Index (LSI) allow efficient querying of data beyond the primary key. DynamoDB is versatile and supports various use cases. Web applications for user profiles and session storage. IoT applications to manage telemetry data from devices. Gaming for leaderboards and saving game stats. E-commerce to store product catalogs and shopping carts. It's perfect for any application requiring low latency data access at scale. DynamoDB Streams is a powerful feature that captures changes like inserts, updates, and deletes in a table. It enables real-time processes for use cases such as event-driven architectures, where changes can trigger AWS Lambda, data replication across regions, maintaining audit logs for table changes. This helps you build reactive and distributed systems efficiently. Now, let's take a look at how DynamoDB streams interact with AWS Lambda using this diagram. On the left, we have a client application. This is any program that inserts or modifies data in a DynamoDB table. Once the data is inserted or changed, DynamoDB streams capture those changes. A stream keeps a log of all the changes happening in the table in time order. Next, AWS Lambda calls the DynamoDB stream for any new changes. When it finds an event, it processes the data. Finally, Lambda triggers a Lambda function. This function can be customized to perform actions like sending notifications, updating another database, or triggering other AWS services. This setup allows you to automatically process changes in DynamoDB without managing servers, making it a powerful example of event-driven architecture. DAX is an in-memory caching layer for DynamoDB that significantly reduces latency for read-heavy applications. It's fully managed and compatible with the DynamoDB API, making it easy to integrate. Use it for applications like gaming or media streaming, where ultra-low latency is essential. Now, let's talk about AWS DAX or DynamoDB Accelerator and see how it works using this simple flow diagram. First, the application sends a write request to AWS DAX. This is marked as step 1 in the diagram. Next, in step 2, DAX forwards this write request to the DynamoDB table. Then, in step 3, DynamoDB processes the write operation and sends the updated data back to DAX. At this point, DAX updates the cache with the new data. Finally, in step 4, the updated response is sent back to the application. So, DAX acts like a write-through cache, which means it writes data to both the cache and the database at the same time. This ensures faster rates and better performance for applications that need real-time access to data. DynamoDB provides robust backup and restore capabilities. Continuous backup through point-in-time recovery allows you to recover from accidental data loss. On-demand backups let you create snapshots for long-term storage. You can restore a table to its previous state quickly, ensuring business continuity during disasters. Global tables provide fully managed multi-region replication, enabling low-latency access for globally distributed applications. With automatic conflict resolution, it's perfect for use cases like global e-commerce platforms or real-time collaboration tools. DynamoDB ensures data security with encryption at rest using AWS Key Management Service (KMS), fine-grained access control through IAM policies, private network access via APC endpoints, logging and monitoring API calls with CloudTrail for visibility and compliance. While DynamoDB is powerful, it has some limitations. Querying is limited due to NoSQL constraints. Managing throughput requires careful planning to avoid unnecessary costs. Partitioning and indexing require a solid understanding to optimize performance. To manage costs effectively, choose the appropriate capacity mode, on-demand for unpredictable traffic or provision for steady workloads. Use auto-scaling to adjust capacity automatically. Monitor usage with AWS Cost Explorer and use DAX to minimize read cost for large-scale applications. So let's jump on to the hands-on. Currently, I'm in AWS Management Console. Now go to DynamoDB. So this is the Amazon DynamoDB dashboard. You can see here, DynamoDB is a fully managed key value and document database that delivers single-digit millisecond performance at any scale. On the left-hand side, you can see here dashboard tables, explore items, backups, export to S3, and also DAX clusters. And coming to the pricing, DynamoDB charges for reading, writing, and storing data in your DynamoDB tables, along with any optional features you choose to turn on. DynamoDB has on-demand capacity mode and provision capacity mode, and these modes have pricing for processing reads and writes on your tables. Okay, now create on table. I'm going to give my table name the customers. Okay, partition key. As I said, partition key is a part of the table's primary key. It has hash value that is used to retrieve items from your table and allocate data across hosts for scalability and availability. Okay, for the customers table, I'm going to insert the customer detail. So the partition key, that means the primary key would be customer ID. The customer ID should be in number. These are data types, that's why I'm choosing number. And sort key is an optional, so I'm not going to select it. Coming to the table settings, you can see two table settings are there. One is default settings, another one is customers setting. The fastest way to create your table, you can modify most of the settings after your table has been created. To modify, you can use the advanced features to make DynamoDB work better for your needs. For the customer settings, you can see here there are two types of table classes. One is DynamoDB standard, the default general purpose table class recommended for the vast majority of tables that store frequently accessed data with low throughput. That means reads or writes as the dominant table class. And coming to the DynamoDB standard AI, recommended for tables that store data that is infrequently accessed with storage as the dominant table class. And you can also calculate the estimated cost. You can see here the average item is like 100 KB. The estimated cost will be $73.67 per month. So that's it. Yeah. And coming to the read or write capacity settings, there are two types of mode. One is on demand and another is provision. On demand means simply billing by paying for the actual reads and writes your application performs. Provision is manage and optimize your cost by allocating read or write capacity in advance. Like you can read capacity set by the auto scaling, like minimum capacity will be like 5 and maximum capacity is 10. Target utilization would be 70. And also you can set the right capacity by using the auto scaling. But I'm going to choose the default setting because I don't need to customize anything. Like in the default settings, you can see here is that for the table class, it automatically selected the DynamoDB standard for the capacity mode on demand and deletion protection is off. Source-based policy not active. Encryption key management is honored by Amazon DynamoDB. That's it. Click on create table. Okay, now you can see here the status is active. Go inside and you can see the overview of the table. Partition key is customer ID. It's in number. There is no sort key. Capacity mode is on demand. Table status active. Okay, now we need to insert some data. So before that, we can see the indexes and we can also monitor using the Ultrams, CloudWatch, global tables, and also there's a backup also. And so overview, explore table item. There it is. You can see here create item. Click on create item and the customer ID V1. And if you want to add new attribute, click on new attributes and strings because I'm going to give the customer name. So that's why the name will be Alex. Add new string. City will be New York. And country US. Create item. You can see here data has been stored. And also I need to add one more data. So do I'm going now same string name will be Zach. And I'm going to give number because it will be age. The new attribute will be age. The age will be 25. And now I'm only giving the city, London. That's it. Now you can see here the data has been stored and also a new attribute has been created that is called page. And in the scan or query items, you can filter this data. I will show you. I'm going to select the customer details table. In that specific attributes, I need only city. So I'm going to type the city and click on run. You can see here. Okay. It's showing according to the city attribute. Now I also need the customer ID. See, and in the query, uh, we can select using the customer ID because that is the primary key, right? That's why I'm going to select customer ID number one. I need this user city. So the customer one city is New York, and also I need his age. He don't have any age, that's why it's okay. I'm going to select a name. His name is Alex, and this is it. And you can also back up your data and export to S3 or import from S3. You can do that. And here I'm going to reset it and run. You can select and go into the action. You can download the results to SCV. It will display in the Excel sheet. And also you can duplicate it, edit it, or delete the item. And that's it. Thank you.